And this distribution will be the Poisson distribution. Now, in fact, it is very related to the exponential distribution from the previous lesson. It looks at the same underlying phenomena, namely processes where there is on average a fixed number of events happening per time unit. For instance, lightning strikes per hour during a thunderstorm, bus arrivals, natural disasters, but also hospitalizations and website traffic. But let's take the example of the previous distribution. You look out of your window and you see on average 2 cars per hour passing by. Now, in this case, you are not interested in the waiting time between events. No, you are interested in the number of events that happen per hour. So it's on average 2, but sometimes you will get more and sometimes you will get less. Now, if you spend an entire day watching out of your window, which I don't recommend, and for each hour you count the number of cars passing, then you will get a data set that will be distributed according to the Poisson distribution. Now, the specific Poisson distribution will depend on one parameter. Again, the rate parameter, which represents the average number of events per time interval. Now, this parameter doesn't change the shape all that much. If you go very low on this parameter, you will get a very skewed distribution. If you go very large on this parameter, then this distribution will in fact approximate a normal distribution. Now, an interesting consequence of the fact that we're now looking at a distribution where our random variable is actually a number of events is that this time we will have a discrete distribution. Now, for the histogram, this doesn't change all that much, but for the theoretical probability density function and the cumulative distribution function, which previously were just smooth functions, we now only have single values. And this is depicted or visualized by only having values at these integer numbers, at 0, at 1, 2, 3, 4, 5, 6, and so on and so on. But just remember that these dots are the theoretical distributions and that the light blue lines or the light blue bars are the generated values for our dataset. Now, in our code, the Poisson distribution is again very easily generated. We only have one parameter, lambda, and the Poisson distribution is just numpy.random.poisson, one parameter, and the size is again the number of samples in our distribution. Now, you should get comfortable with discrete distributions because in fact, our next distribution is also a discrete distribution, namely the binomial distribution.